SwayamPrabha. Digital India. Educated India.
Welcome back. In lecture 10, we will talk about cost of water supply. So, the different concepts that will be covered in this particular lecture are state of urban water supply in India, cost recovery and types of cost, tariff design, some key measures, and finally tariff setting. So, when we talk about the state of urban water supply in India, the first thing we would like to say that the water supply in India is being, even though it's is provided by several corporations in some cities it is being done by the municipal corporations, but still in most cases we have seen the delivery of services has been largely inefficient, and we call it inefficient because of two reasons. One is there is lot of highly unaccounted water which is around 30 to 50%. That means unaccounted water is basically the water for which we cannot say exactly that what has happened with that particular water. So, for example, that water could have been lost due to leakage, this water could have been stolen, this water could have been used by somebody, but there is no trace of that particular who has used that particular water. So, this is lot of highly unaccounted water. So, 30 to 50% of water is unaccounted, and intermittent water supply. That means intermittent water supply means we are not able to provide a supply for 24-hour period, but we are supplying it only for certain time periods. And usually we see that municipalities will provide either for a couple of hours in the morning or in the evening, or maybe during two time periods either in morning and evening. So, that is what we see, and it's intermittent water supply in general, it's a inefficient service, because you have to take care of water. To store the water, you have to first store it in an underground reservoir, then you have to pump it to overhead tank and then use it in your building. So, inefficient in that particular way, and it's a highly unaccounted water means it's another inefficiency, but it's the inefficiency at the level of the company which is actually undertaking this utility provision or this water supply provision. So, this is one major thing, and then of course, most of the Indian urban areas doesn't have piped water supply in its entire area. So, inadequate coverage is the other issue, and so piped water supply is still yet to be reaching many of the parts, and some of the poorest sections of the city like slums and all, they don't have water supply. One of the reasons because some of these slums are some of the slums are not registered, and so government is unable to provide water supply to those particular slums, and because of the provision the space is also not there to take in the water pipes and then provide water supply from door to door as well. So, this is the status of urban water supply. Now, when we talk about intermittent water supply and continuous water supply, or for a 24-hour supply, in case of a developing country or a poor country, we really have to be very careful about which method to adopt, right. So, sometimes we say that, well, 24-hour supply is obviously better, but there are some pros and cons to both of this. So, for example, in case of 24-hour supply, we need to periodically check, and we need to see that all the joints and meters are proper, if they are not leaking, and so this kind of periodic checking has to be done, which is not required in a intermittent supply to that extent. But of course, we need to check for leakages and other kind of issues for pipelines in all cases, but particularly in case of 24-hour supply, we have to be very careful. Then constant pressure in the distribution pipes lead to higher leakage, and what we see is increase of head from 20 meters to 30 meters will increase leakage by 20 to 30%. So that you can understand. That means because the pipe is continuously under pressure because of 24-hour supply, then automatically the leakage volume will increase by many-fold. And in case of intermittent supply, leakage loss is less, but people throw away old stored water and sometimes leave their tap open. So in case of intermittent supply, what people do is they sometimes store the water because in the intermediate time period when there is no water supply, they will use this stored water, and when new water comes in, they will just throw away the old water. So this is some big problem. And in case of metered connection, people are usually more careful, and that and 24-hour supply also means that the water supply has to be metered, right? That means it has to be we have to measure how much amount of water is being consumed all throughout the day. And so there in case of metered connection, even the people are careful to use less water, but sometimes in case of poor families where they cannot afford that much amount of water, so they will actually use less water, which may result in unhygienic conditions. And similarly, metering also reduces water pressure, and the maintenance requirement is also increased because of metering. So these are the different things, even though metering is not directly connected with 24-hour supply or intermittent supply, but it has to be there if there is 24-hour supply. So these are the different issues one should consider while determining which sort of system should be adopted. But primarily 24-hour supply is of course a better level of service or a better quality of service, but it is also going to cost, or it also requires more amount of more amount of maintenance, more amount of cost, and so on. So and for unaccounted water also, because we are talking about metering and unauthorized connection detection and checking is required to reduce the volume of unaccounted water, and that is also one of the biggest challenge in Indian urban areas. So in addition to that, in this two main challenges, inefficiency, coverage, and so on, we see other kinds of challenges, like for example poor cost recovery. And because poor cost recovery means the water utilities or the companies which actually are charging for water, or they are trying to get some amount of cost, some amount of money because of these services by different ways. We will discuss that later. But usually they are able to only recover a small part of it, and that's why in most cases they are financially non-viable on their own. They have to be subsidized. And in India, most of the water utilities are subsidized, and because they are subsidized, they are non-independent. That means city have or state level water supply boards or municipal corporations are the ones which usually supplies water, and they are directly under the control of the government. So based on government's decision, they have to also decide. So if an independent entity, maybe a private company, was supplying the water, they would have they should be able to charge their own tariffs. They would be able to propose improvement into the supply without any consideration of other interventions. So independence is also not there. So because of subsidy, this particular corporations are also cannot take that kind of independent decisions. So this is another challenge in India. So the prices for water that is being charged in India or recovered in some other way in India, this is also not based on the actual cost or the economic cost of water. Instead, it is based on socio-political considerations. So that means it depends on, because if you charge too much, then people will be angry, and the government in power will lose a lot of political capital and usually will probably lose its next election. So that's another reason why prices are artificially kept low. And this underpricing itself has got a lot of other problems. For example, this underpricing leads to not only poor service quality, and there is also a lower chance of expanding the network, because you don't have money for expanding the network. So coverage remains as it is, right? So these are some of the challenges. Then revenue from tariffs is inadequate for capital investment, and even 50% and even in some cases 50% lower than the operation and maintenance cost, except for a few cities. So of course, whenever we are talking about expansion of the network, that means it requires capital investment, but in the amount of money that we can actually generate is actually even lower than the total not only the capital cost, forget capital cost, we can barely manage to fulfill the operation and maintenance cost, and in some cities it is even 50% of the operation and maintenance cost, right. So these are the different challenges that are there in India, and in the table you can see that this is sort of an estimate made by this particular in this particular report. It was estimated that for this particular cities like Dehradun, Ludhiana, Chandigarh, Indore, Pune, Hyderabad and Kochi, there is chance of improving the revenue potential through improving the operations, of course. That means there is chance to improve the revenue to a large extent. For example, there is chance to reduce total non-revenue water, and that could lead to around 21 million rupees improvement in revenue in case of Dehradun. Then by improving the collection efficiency, that means to making the bills and all proper and to actually charge people, that could lead to around 37 million rupees, that could be there improvement. And then increasing the consumer base, that means by increasing consumers you can add another 90 million rupees, right. So overall, if you add all this up, it comes to around 148 million rupees, whereas the current revenue is around 130 million rupees. So this is actually around 114% increase in the potential to increase income for this particular water supply agency. So similarly, for Ludhiana, it has been estimated at 226%, that is twice, it is that increase is around 2.2 times more. Then 44% for Chandigarh, 444% for Indore, for Pune 68%, for Hyderabad 83% and Kochi 208%. So there is potential, there is chance to improve the amount of revenue that is collected in Indian urban areas, and for that you have to increase the consumer base, we have to improve the collection efficiency, and we have to reduce the amount of non-revenue water. So some other issues that we face in India are the urban poor suffers the most. The reason is there is something called coping cost, or the coping strategies, you can say. So there are a lot of the urban poor in slums and all, they don't get water directly to their homes. So they have to go travel a certain distance, then they have to wait for the water to come, then they will actually bring the water back, and because of this the amount of water consumed is less, the quality of water is poor, and that leads to a lot of diseases and all. So there are a lot of cost which gets added upon because they are not getting a good water supply, or good quality and good quantity of water supply. So this tangible and intangible cost, this which actually results because of this coping strategies like collecting or treatment of water, that because those are not proper. So these are the extra costs that the urban poor has to pay. So even though they don't have to pay money as such for the water, but they have to pay money for other costs, and that actually is where you will see that people are actually willing to pay more in many cases for water and this kind of services in urban areas, but that is usually not considered. So people are, because they have understood that if I get water, then these are the other costs that I would avoid. So this coping cost or coping strategies actually increases the cost for the poor compared to the normal people, or compared to the richer people, or people who pay taxes, or people who pay water charges. So tariff structure varies from city to city, and as we have seen in India, there is no rationale for any kind of tariff fixation. So that means in different cities has adopted different kind of tariff structure, different kind of levels at which they have fixed their tariff, and there is no rationale for any one of them. And in many cities, what we see is water and sewerage charges are clubbed together. So the amount of money that is being charged is basically not only for water supply, but both for water and sewerage charges, which are put together. And usually these are taken in form of taxes. Maybe it's a fixed charge based on your annual rental value of your property, based on the size of schedule, based on many things, right? So it's a fixed charge, and usually we assume that a certain proportion of the charge that is there for water, based on the volume of water that is being consumed. In case of where there is measurement of amount of water consumed, we assume certain percentage like 50% or 60% of that particular charge which would be taken for sanitation, and accordingly we divide the amount of money. So there is no separate accounting for cost of water supply, which is required, because then only you can understand how much is the cost of actual service provision, and actually you can recover that amount of money. So this is another problem. And then consumer metering is difficult due to high capital cost. Many of the utility providers themselves say that it's not only the people who is reluctant to use meters, but also this utility providers, they also say that there is a huge amount of capital cost involved to provide these meters initially, and there is no money to spend this much amount of money in provision of meters and so on. So these are the other challenges. Then main operation and maintenance cost component. The one major cost component is electricity charge. That means out of all the different costs that this utility providers actually has to pay for provision of services or water supply services, the main cost is electricity charge, and that accounts for around 50 to 60% of the total cost. So if this amount could be saved, there could be a lot of savings as well. So households are mostly subsidized, and another issue that we see in India is households are mostly subsidized based on consumption level and not their income level. So that is again another challenge that we have to, that is another point that we have to consider when we determine future tariff revisions or future tariff settings. So now that we have talked about different types of costs, like we were saying that the power is the most, 50 to 60% of the total cost is because of power, but there are other costs as well. So total revenue by the utility provider should be same or more than the cost of supply. But in India, what we see is there are three types of cost recovery models. So out of that, the operational cost recovery only model, that means we are not concerned about the capital cost. Capital cost would be one-time cost that would be given as a grant by the state government or by the central government, whereas the operational cost recovery part has to be taken care by the service providers. And this is expected in Indian conditions. Whereas it is as per the SLBs, you have seen that 100% cost recovery, but that is for operational cost recovery. But for full service cost recovery, which includes both the capital and maintenance cost, that is the eventual target. And many developing countries and many governments, usually they target to not only operate and maintain those particular infrastructure, but also expand the infrastructure and so on, or replace the infrastructure and so on. So if utility providers are not linked with government, they can independently decide on operations. And so this is another issue that comes along. That means if utility providers totally separated from the government, that means they have to provide both for capital expenditure as well as maintenance cost, and then they are also free to expand their services, and not only expand their services, they are also free to set their own tariffs. But of course, this cannot be without any kind of oversight. So even when they are determining what kind of operations, what kind of service levels they would provide, then they have to set all this within a regulatory framework. So eventually in India also, if we go for this full service cost recovery model, we have to have regulatory frameworks determining what sort of service delivery has to be provided, and also there has to be third party review of tariffs. That means there has to be a third party review which determines if the tariff setting for this by this particular private entity or this company which would provide water supply services, this is right or wrong, right? So, or what kind of subsidies could be given, so that could be determined by this third party review. So this is what the full service cost recovery model would look like. eventually. And then there is another model which is a full environmental cost model, which is not only full service cost recovery, but also external cost of a service are also considered. That means environmental cost, maybe certain other external cost which were not like pollution cost, and all these things are also considered as a part of the service. But anyway, so this is where we are targeting service right now in India, and then eventually in future we have to target full service cost recovery. So let us look at the different types of cost that is usually there for provision of water supply services. There are fixed costs and then there are variable costs. That means certain costs would be there which would not depend on the volume of water that has to be supplied, but there are certain costs which depends on the volume of water that has to be supplied. And then there are both direct cost and then there are indirect cost. Direct cost is related with the water that is being supplied, and indirect cost is like establishment charges, administration charges, which are indirect cost, but which are also part of the overall cost structure. So let us look at the different kind of costs. Like fixed cost, we have for different parts of this water supply, like transmission, treatment, distribution and other aspects. We see that in the transmission stage there is cost of power which is fixed, there is cost of manpower which is also fixed, and then there is cost of fixed repair and maintenance. Whereas variable cost depends on power cost, usage charge. So some amount of power cost would be variable based on more amount of water being consumed, more because the pump has to run more. Bulk water rates, that means it depends on the, in most cases this utility providers has to buy the water from state boards, right. So this buy the water means they have to buy the water from other departments in bulk water rates, and they have to pay that money to those particular departments, and this bulk water rates changes as per the consumption and royalty that they have to provide. And then for treatment, again we have got power cost, manpower cost, repair and maintenance cost, and same for distribution as well. Whereas for treatment the variable cost is power cost, chemical cost and fuel cost. This will vary as per the volume of water. And for distribution, power cost, the horsepower of pump has to be more for higher amount of water to be distributed, so power cost also varies. So in addition to all this, there are some other costs like interest on loan, interest on working capital, depreciation, return on assets, which we will discuss in the next page, in the next slide. So when we talk about the different types of costs and cost recovery, we see that manpower cost is mostly fixed and on the basis of the number of employees. So it is a fixed cost that you have to pay whatever the consumption is, and power cost could be both fixed and variable. So some of the cost is fixed, like this amount of minimum power requirement would be there, whereas some amount depends on the consumption. So like treatment and pumping, horsepower of pumps installed at transmission, distribution. So some of these costs are both fixed and variable. And then bulk water rates, as we are discussing, cost to acquire water from source. ULBs buys from state water bodies at bulk water rates. So this is the water that ULB or a municipal corporation has to buy while supplying water. Chemical or treatment cost depends on water treated. Repair and maintenance cost depends on cost of major replacement. For example, pumps, major and periodic maintenance, including material cost. So all these things becomes part of the cost structure. And some other cost which we are discussing, which we are mentioning in the last slide, like interest cost. So these are other costs, and these are capital recovery cost components, where you see that interest cost is basically depends on the loan amount, and of course for any kind of execution of any kind of project or any kind of work, a loan, if it is taken for a particular project, then we have to pay interest for that. So this is the interest cost. Interest on working capital depends on the working capital needs of the ULB. That means sometimes for a yearly operation, the ULB takes a loan or the working capital, and for that they have to also pay interest rate. Then depreciation is different kind of equipments are involved, transmission equipment, distribution equipment, water treatment plants, and because these are equipments, this kind of assets has to be replaced. So and because of use, their values depreciate over different years. So this depreciation rates are considered. That means every year some amount of money is being deducted because we are using this particular asset. And then once it reaches its end of life, we have to buy a new asset, right? So we divide the overall cost of the asset over a different over different years. So that is what depreciation is all about. Then reasonable return on investment or equity depends on assets not financed through loans, and then and the required rate of return. So in case it is based on my own resources, that means I have invested that money, so there has to be some return to that. So in case I am trying to recover the entire cost, so that also is considered. Life cycle cost is cost of creation of a sinking fund for additional investment in future. That means in future I need to invest or increase my coverage, so I will increase I will save some money now for future. So this kind of inflation rates and replacement cost of equipment, all these things are thought of, and this requires a creation of a sinking fund, and for that we have to also consider money. So these are the different costs that are involved in water supply system. And not only water supply system, even in sewerage network design and all, similar kind of costs are also there. So next we come to tariff design. Tariff design is basically the rate which is charged from the people for supply of water, and tariff design enables financially viable service delivery, and this can actually reduce wastage. If there is no tariff, then people will waste water. If there is some amount of tariff, people will be aware of that, and then they will conserve water. So that is the idea behind setting of tariffs. And then different types of charges are there. These are fixed charges. For example, when we set these tariffs, there could be different types of tariffs. One is based on fixed charges, that is usually in case of non-metered connections. Tariff level per unit value is same, and we use there could be different ways we can charge this value. It could be a flat rate charge for each household. It could be a ferrule based charge. Ferrule is the connection given to a particular household to take water from a municipal supply line. Ferrule size diameters could be vary as per the requirement of that particular household. You have to spend some money to actually get a ferrule connection, and the money that you have to also spend depends on the diameter of that pipe that you would get a connection, and that diameter of the pipe determines how much amount of water you'll be able to get, right? So that's a ferrule based connection. So if you have a higher ferrule size, you have to pay more charges, right? Then annual rental value of property, that means based on the property tax. Usually property tax is set based on the annual rental value of the property, and a certain portion of the property tax is taken as fixed charges for water supply, sanitation, and just maybe also for water supply. Or tap based charge based on the number of taps that are being supplied. So these are the different ways fixed charges could be set. And then there are volumetric charges. For example, volumetric charges means as per the consumption, that means if you consume more volume of water, you will be charged more. So to make sure that if there is volumetric charge, there has to be a metered connection, and of course depending on the volume of water, the charge is being set. And then there could be different ways this volumetric charge could be set, or this volumetric tariff could be set, such as flat rate per cubic meter. That means for each cubic meter of water we can set a charge. So more the amount of consumption, more would be the charge. So if I take 10 cubic meters of water, I will spend, suppose example, 10 rupees. So if I spend 20 cubic meters of water, if I consume 20 cubic meters of water, then I will spend 20 rupees. So it's a flat charge. Or it could be something like a block tariff. Block tariff means where different rates are applied at different levels. So it's a block. We create separate blocks of tariff, right? So for certain consumption volume, we create some tariff. If the volume is increased, then we create, for the next block we have a different tariff. So there could be different ways we can set that. So it could be like an increasing block tariff. That means the initial block rate is fixed at a value which is a lower rate, but if the rate is more than this, that means you consume more than so many kiloliters of water, or so many meter cube of water, then the next block rate is higher. If you even consume further, you falls on the block rate after this, then your tariff would be even higher, right? So, usually when we set an increasing block tariff or IBT, which is the popularly known as IBT, so we keep the basic service level block rate cheaper as per, and usually it is as per the typical household consumption, maybe a household of family of 4 or 5, we assume that so many kiloliters of water will be consumed, and we based on that kiloliter consumption, which is around 6 to 10 meter cube per month, and we set a tariff which is of reasonable volume. That means for so many meter cube, for each meter cube you have to pay so much amount of money. But anybody who is consuming more than 10 meter cube, we can ask for a higher tariff. That means for the rate of money that you have to pay per meter cube would be much higher compared to the first block. So, this is the increasing block tariff. Similarly, there could be a decreasing block tariff where the first block is higher, then the more you use, it is not that high. So, it depends on, in case of India, increasing block tariff is more viable because we have to provide for standard poor families, and then for larger consumers we have to charge more, and usually for commercial consumers we usually charge much higher. And but in places where water supply is not an issue, there is adequate supply and all, then they can have a decreasing block tariff, right? So, that is also possible. So, initially it's high, then for more use they don't charge that much extra. So, two parts. So, both of this volumetric charge and fixed charge that we are discussing are single part charges. So, similarly, there could be a two part charge where there could be a portion which is fixed. That means you have to pay a certain amount of money, which is the minimum amount, plus a part which is volumetric charge. And then a portion of the money which is based on the volume of water you charge. So, these are the three ways, or not three ways, actually volumetric charge could be again of different types, but broadly these are the three ways in which we can, or in which tariff is actually designed. So, this shows you, a case study of a few cities like Ahmedabad, Raipur, Bangalore, Delhi and Chennai, where we see that this actually gives a snapshot of the status of water supply in these particular cities, where we see that the capital works for water supply, that means new projects, new investment is done by the PHED. This is the Public Health Engineering Department for this particular state, and then the operation and maintenance work is taken care of by the municipal corporation in both the cities, right, in Ahmedabad and Raipur. And in case of Ahmedabad, a flat rate 30% of property tax is being charged, and water supply and sewerage is being done together, and total recovery is around 110 crores, which is about 60 to 60% of the overall operation and maintenance cost. And metering is not there, it's negligible value, negligible amount, and losses around 20% of the bulk water is lost. And revenue collection, around 70 to 75% of the billed value is being actually obtained as revenue. So, collection efficiency is around 70 to 75%. Similarly, for Raipur, you see that it's a flat rate based on schedule size, and the charge is something around INR 0.70 paisa per liter, whereas the cost of production of this water is around INR 2.84 per liter, which roughly comes to around 25% of the amount of water operation maintenance charge is being recovered in this particular case. And we see that losses is around 50%. Why this 50% so high loss? Because 7,000 public taps are being provided, which actually there is a lot of loss of water in this public taps. Then in Bangalore, we have the Bangalore Water Supply and Sewerage Board, and as you can see that in this they do both capital works as well as operation and maintenance. And here in Bangalore is one of the only cities where volumetric charge tariff is being set, and rates are revised every 3 years, and sewerage charge is separate. So, Bangalore is pretty advanced in that way, and full cost recovery is being undertaken at no profit and no cost loss basis, and total cost of service is around 12.98 per kiloliter, whereas recovery is around 13.79 per kiloliter. So, Bangalore in case of Bangalore, because it's a volumetric tariff, we see that 100% is being metered both at the supply and the consumer side. That means the consumer has got a meter, whereas at the supply end, wherever you are supplying water from the treatment plants and all, we also have meters to determine how much amount of water is being supplied. So losses still around 50% is lost, and around 90% is the revenue collection. So in case of Delhi, Delhi's water is supplied by the Delhi Jal Board. 90% of this water comes from Jamuna, rest from groundwater, and they have got a two-part pricing model where fixed connection charge as per the dwelling and consumer category, and volumetric charge based on block tariff rate. Right, and 60% of the charge is for sewage. So you see different, flat rate, volumetric, and different parts of the city, different parts of the country, different kinds of charges are being set. So in case of Delhi, you see the initial cost of water provision is 2.30 per kiloliter, INR 2 rupees 30 paisa per kiloliter, and the charge that they set, this is sort of a volumetric charge, where for the first 10 kiloliters the charge is INR rupees 2 per kiloliter. For the next 10 to 20 kiloliter it is INR rupees 3 per kiloliter. For the next 20 to 30 kiloliter it is INR rupees 15 per kiloliter. You see a massive jump there, and greater than 30 kiloliter it is INR 25 per kiloliter. So commercial customers are even charged at a much higher rate. So metering is around 76% domestic and domestic consumers, and 96% for non-domestic consumers, and 50% of the water is lost. In case of Chennai, water is supplied, operation maintenance and capital work is both done by Chennai Metropolitan Water Supply and Sewerage Board. Volumetric tariff for metered consumers, they have got both volumetric tariff and flat rate for unmetered users, and monthly charges for based on meter reading. That is also being charged. That means because of the meter reading charges, and cost is around 6.09 INR per meter cube, whereas charge is around 10.87 INR per meter cube, and 3.5% consumers are metered, and 17% of the water is lost. So at least the loss volume is very, very less. So this actually shows you the status of water supply in many urban areas, and when you propose in your particular urban area, if you propose water supply, you have to also think similar kind of tariff patterns, similar kind of recovery and or similar kind of management structure, or different kind of will you do both the capital works or just the operation maintenance works, and so on. So next we talk about some of the key measures based on which usually water supply system is being evaluated, or rather when we decide on the tariff structure, we usually take into consider this kind of key measures. The first one is economic efficiency. So what it means is the charges that would be collected by the utility provider should be adequate to meet the marginal cost of supply. So that means the cost of supply should be actually made by this utility service charges, and it should be elastic, as we have already learned that water supply charges are a bit inelastic, but it has to be elastic considering population, household income and inflation. So the charges will vary as per these different situations, in case of different population groups, in case of different income groups, or in case of inflation. In many cases, utility charges has to be kept fixed for long periods due to socio-political reasons in many cities, which is also not ideal. Like in Kolkata, the charges are not there at all. So in equity and then comes this. So these are the different economic efficiency considerations. Then the equity and affordability considerations. This is where subsidies are provided, and they are often used to achieve equity and enable low income households to gain house connections or to make service affordable for the poor. So that means even though maybe people are able to pay the operation maintenance charges to get a new connection, there has to be some amount of subsidy, and so to make the service available for the poorest of the poor, so there has to be subsidies. So this has to be looked into. And similar customers should be charged equally. That means similar group of customers should have similar kind of charges, whereas other groups of different characteristics should have different charges. And both cost of access, the connection charge, and user charges should be affordable and has to be set as per users' willingness to and willingness and ability to pay. So if people are not able to pay for those charges, but still that means it has to be subsidized. So that is why equity and affordability is considered while setting the tariff, right. So it's not only about economic efficiency, it's also about equity and affordability. Both has to be considered while we set the tariff structure for a particular urban area for water supply, of course. Then operating ratio needs to be considered. This is measured as the operating expenses divided by revenue. And then for non-revenue water, we need to understand free water supplied through, this is basically the free water supplied through the different stand posts or like the public taps, and then the different amount of water for which people don't pay. That means because of theft and then lost due to leakage. So these are the different non-revenue water or unaccounted water. So this has to be reduced, and then only you can improve the overall tariff structure, or you can provide the services at a lower tariff structure. Then subsidy, we already discussed subsidy when we were discussing equity. Like in India, subsidies are going to stay, but tariffs also has to be increased as well gradually. So it's not only about the subsidy, but gradually even though subsidy is going to stay, the tariff still needs to be increased a little bit gradually over time. And subsidy and grants is mostly used for capital cost that we discussed earlier. And there are two models of subsidy that could be provided. One is a direct subsidy and the other is cross subsidy. So what is direct subsidy? This is where certain desirable customer groups are directly given some amount of money, whereas other customers are not given that amount of money or that amount of subsidy. So it's a direct subsidy from the government directly to that group which cannot afford certain things, right, or which is actually facing the problem. But cross subsidy is like taking the money from one group and giving it to another group. So and this cross subsidy varies between the different groups, and this is where sometimes people get angry, like they are not willing to if you take money from the higher income groups, even though they are consuming less water and giving it to another person who is consuming more water, but from lower income group, obviously there will be discontent, right. So that's why out of cross subsidy and direct subsidy, it's better to go for direct subsidy models in case of water supply. The IBT structure seems more appropriate, this increasing block tariff that we discussed earlier, and where more appropriate, this is more appropriate in considering India, and we could set the initial blocks or this initial charges by considering a basic lifeline consumption quantity charge. So this lifeline consumption quantity is the basic quantity that is required by all families. So we can create our first block based on that, and then subsequent blocks could be charged higher rates, right. So this is the basic amount of water that has to be supplied. Then when we talk about subsidy, we also has to be very transparent exactly how much amount of fund is being received either through direct or cross subsidy and where we are utilizing them, right. So this transparency is also key when we talk about subsidy. Then other things that also influence or other things that are also plays a role is the capacity building of that particular utility service provider. Training programs on skill upgradation of personnel and adequate infrastructure facilities, this actually reduces cost. Employee per 1,000 connections, we have to bring down the number of employees. Usually we find around 15 to 25 employees, whereas ideal value is around 5 to 10, right. So that is per 1,000 connections. So that is in case of India, it is around 15 to 25. So we need to bring it down. Data and transparency, so the more data we can save and more transparent the processes, we would be able to make better estimates and we would be able to avoid losses, right. So based on fluctuations, we can actually supply that amount of water and not send extra which would be lost. Then accurate billing and accounting system improves cost recovery and reduces unaccounted water. So the more better the accounting system or the billing system is, the better is this parameters. Improve service quality and consumer satisfaction. So overall, when capacity is better, capacity building results in better service delivery and people are more satisfied. So and then if they are more satisfied, they will be willing to pay more, right. So willing to pay or WTP is the next dimension that has to be also considered. And what we see is WTP for various levels of improved services. We need to talk with people and find out that how much they are willing to pay and what kind of improvements they want. So, these are key to service water supply service delivery in urban areas, and existing studies show that consumers are sometimes willing to pay even 2 to 3 times higher charges, since they have to actually pay more in terms of coping cost. So, this is particularly good true for poor consumers. So, they are willing to pay more because now they are paying actually, even though they are not paying any taxes or charges, they are paying more because of coping cost, right. And sensitivity of customer groups to proposed tariff changes. That means which are the things, if I change my tariff or if I change my service quality, which are the aspects which people want to change. So, sensitivity of different customers groups would be also different. This needs to be also looked into. So, these are the different aspects that we need to consider when we set our tariff. So, tariff policy and tariff setting should be part of as per the goals of this particular community, and these goals are in terms of this efficient allocation of community resources, equity in allocating cost, fairness, adequate revenue to operate the utility, simple and easily understood rates, conservation of scarce resources. So, these are the different parameters that has to be considered when we set a tariff for a water supply for a particular community, and it has to be as per what the community wants. So, community's willingness to pay for different service aspects, or like if they are interested in conservation, they will pay more money for conservation, or pay more money for water. Then simple and easily understood rates, it has to be, the structure has to be very clear. Adequate revenue, so that means to make sure the utility operates independently, there has to be adequate revenue. So, maybe the community would like to have that, so that the service remains more professional. And so these are, and the other things, efficient allocation, equity, this already we discussed. So, these are the different things that are considered when tariff is set. Now, some of these objectives that we are discussing, this may be in conflict with each other. That means, if you in like equity and efficiency may conflict with each other. So, what we need to do is we need to do a ranking of objectives for this particular community as per that circumstances or for this particular context, and what is prioritized, what is more important, that should be taken at the first. And we can always take a heuristic approach where we can first design the tariff because there are several objectives. What we can do is we can initially design the tariff based on the most important objective, and then gradually modify it by making sure that all the other objectives are also met, by of course making some adjustments, some compromises. Without compromise, that is not possible, but still we first set the tariff based on the primary objective and then modify the tariff as per the secondary objectives, right. So, this is how, using a heuristic approach, we can actually set the tariff level for a particular community. So, and not only that, we have to do phased implementation of this particular tariff, and then also continuous tariff revision, so that people are aware of that tariff has to be revised and they don't get irritated or angry when suddenly there is huge change in the price. So, that it has to be gradual over time. So, this is how tariff setting has to be done for urban water supply. So, to conclude, introducing metered connections and charging on volumetric basis is essential for reducing volume of unaccounted water and improving the quality of service. However, there is significant opposition to the same, both from consumers as well as utility providers, because of high capital cost. And both consumers, because of high capital cost of provision of these meters. So, there is sometimes opposition from the utility providers as well, and thus tariff setting and cost of operation needs to be analyzed in detail for case to case basis, along with consumers' willingness to pay for improved services. So, this is how we should set tariff for a particular urban area for water supply. These are some of the references you can study. Thank you.